Hey everyone, this is Derek, and this is section 4.2, and in this one we're looking at algebraic solutions of systems. So in the last one we looked at graphing as a method of solving systems of linear equations, and that one has limitations of maybe not being able to read the point. If the solution was 2.718, you're not going to be able to read 2.718 off of a graph. And so having an algebraic way to solve these is definitely necessary. So just as a reminder, in the last video we saw inconsistent systems. The geometry on that was that they're parallel. What we're going to see on the algebra is we're going to get false statements. We're going to do some algebra, all the letters are going to drop out, and we're going to get stuff like 0 equals a number, or some untrue statement like 7 equals 3. And so when we see stuff like that, that's telling us we have an inconsistent system. For dependent, same thing, the variables are going to drop out, but we're going to see 0 equals 0, or like 7 equals 7, for instance. So some sort of true statement, but one that isn't helpful. So that will be our heads up that we have a dependent system. So solving by substitution method, there's some steps here that you can follow. Basically what we want to do is isolate a variable if one isn't already isolated, and then we're going to, since we're looking for the point where this y and this y are the same thing, if I know y equals 5x minus 7, I can take this and drop it right into that second equation for the y, which is what step 3 is saying, and then that gives me an equation in terms of x, and then we can solve that. And then once we know x, we can toss it right back in here and get y. So here they're saying that y equals 5x minus 7. So what I'm going to do is I'm going to take this equation, 7x minus 2, and instead of having 2y, I'm going to have minus 2 times that 5x minus 7, because that's going to stand in for the y. And now that equals negative 3. So that's the substitution, is we're substituting this equation into that one. And then we just solve it for x. So 7x equals, minus 10x plus 14 equals negative 3. Down 7, down 10 will be minus 17x plus 14 equals negative 3. Take the 14 over, and negative 17x equals negative 17. And then dividing double negative will give us x equals positive 1. Once we got this, we can come over here to either equation, but I'm going to pick the easy one and go y equals 5 times 1 minus 7, or y equals negative 2. So if we graph these, the place where they would have intersected is at x equals 1 and y equals negative 2. Okay, for number 2, this one is negative x plus y equals 3. So we don't have a variable by itself, but that y right there looks pretty easy to get alone. So I'm going to add the x over and rewrite this as y equals x plus 3. And now I can take this and drop it in for the y for the first equation. Careful not to put it back in the same equation. So this will look like negative 3x plus 3 times x plus 3 stands in for y equals 4. So negative 3x plus 3x plus 9 equals 4. These drop out, and so we're left with 9 equals 4. And 9 does not equal 4, and so that is what it looks like in terms of the algebra when you have an inconsistent system. So this one will be inconsistent. Over here, this time it looks like that x is the easiest thing to get by itself, so I'm going to rewrite that as x equals, I'll add the 2y over, 2y minus 2, and now I'll take this and drop it in for, oops, no, not there, you drop it in for x, because it's x equals, so negative 2, and then 2y minus 2 plus 4y equals 4. Distributing, negative 4y, minus and minus makes plus 4, plus 4y equals 4. So we got minus 4y plus 4y. There's that thing where all the variables dropped out again. But this time I have 4 equals 4. So that one's going to be dependent because it came out true. So if they come out false, inconsistent, true, that gives you dependent. Okay, our last and most useful method of solving will be the elimination method. For this, we want to first get both of our equations into standard form. So that's kind of how the system is set up, and that's a pretty normal way for it to be presented. Second, decide which variable to eliminate. Multiply each equation by an appropriate constant so that the coefficients of that variable are opposite. So what we're going to do is we're going to add two equations. We're going to add the two equations together. We want to get coefficients that are opposite. So same number but with opposite signs, so that when they add them together, that eliminates one of the variables. So we're going to eliminate through addition is kind of the idea. And then we eliminate by adding the equations. That's step 3, and we back solve just like we did in the last one for step 4 to get the second variable. So this sounds horrible, but it actually, once you see it, it's not bad. So right now I got a plus y on both of these. I'm going to just call this one equation 1. I'm just going to rewrite it right here. I'm going to call this one equation 2 just to give it a name, and I'm going to multiply it by -1. And the reason is I want to have the same constant in terms of the coefficient, but I want them to have the opposite signs. So if I multiply this by -1, I have -x, -y, that's what I wanted right there, and negative times negative will make that a +4. So now when I add these, and sometimes this is also called addition method because we're eliminating a variable by addition. So when I add these together, 2x plus -x would be x, plus y minus y, those cancel, that's what we wanted. -5 and 4 for -1. Once I have one of them, I can just chuck it in here and get the second one. So -1 plus y equals -4. Add the 1 to both sides, and let's say that'd be -3. So it looks like our solution here is -1, -3. Looks like I pasted these in backwards, so I'll do number 5 first over here. So I need to get again, the same coefficient but with opposite signs. So looking at the x's, it looks like if I do a +2 against this one, I would have -6, +6. I'm also going to get -4, +4, so you can see this is going to be a dependent or inconsistent one. So if I go 2 times equation 1, so again, that's my equation 1 and my equation 2, I would have -6x, 2 times 2 would be -4y, and then -10. 6x plus 4y equals 10. And then check it out, right? Everything just cancels out. So there's our 0 equals 0, so this would be a dependent one. And then number 6 over here, 2's and 3's. So a good way to think of that is what would be your lowest common denominator, which would be 6. So what I'll do is I'll multiply this first equation, and I want one to be negative, one to be positive. I'm going to multiply this first equation by -3. Bad notation here, but hopefully it's at least clear. I'm going to multiply the second equation by +2. So it'll give me a -6x, +6x. I could do the same thing in terms of the y. I was just focused on the x's because they're smaller numbers, and it's not going to matter in a second. So -3 times 2 gives us -6x. -3 times 4 gives us -12y, and then equals -24. And then here we're going to get a 6x plus 12y, and 2 times 10 would equal 20. So on this side, cancels, 0 equals -4. So that one would be inconsistent. Okay, and then in this last part, we'll do some application problems where we have to set up the equations ourselves. Max has been offered 2 positions by 2 car companies. The first company pays a salary of $7,500 plus a commission of $500 for each car sold. The second company pays a salary of $17,500 plus a commission of $250 per car sold. So how many cars did he need to sell to make the total pay the same? So this one's smaller base pay, larger commission, bigger base pay, smaller commission. So we're trying to figure out how much he would have to sell to make those things match. So let's write an equation for the first company. We'll say y, how much he's going to make, is going to be $7,500 plus it was $500 for each car he sold. So I'm going to let cars sold be X and the money he made be Y. And then here he's going to make $17,500 plus $250 for each car. So this is already solved for y equals. So I would definitely do a substitution on this one. I'm just going to set them equal to one another. So I just set these two equal. And now I'm going to get x's to one side, numbers to the other. So subtracting the 250 over to this side would leave me 250x over here. I'm going to subtract the 7,500 on both sides. When I do that, that will leave me 10,000 on this side. And then divide out that 250. And I believe x comes out to 40 cars. Okay, number 8. Troy and Lisa were shopping for school supplies. Each purchased different quantities of the same notebook and thumb drive. So Troy bought 6 notebooks, 5 thumb drives, $124. Lisa bought 2 notebooks, 4 thumb drives, $88. Find the cost of notebook, thumb drive. Okay, so notebook, I'm going to let that be X, and then the thumb drive, I'm going to let that one be Y just to give them letters. So it looks like Troy bought 6 notebooks, so 6X plus 5 thumb drives, so 5Y for $124. And Lisa bought 2 notebooks and 4 thumb drives for $88. So I can solve the system for either Y or X. Here I'd have to bring both these up to 20. Here I would just have to do a -3 to that second equation to bring it this 6 and -6. That looks like less work, so that is the way that I did it, but those are both valid ways to solve. So I'll just copy down the first equation, and then this would be -6x minus 12y equals -264. This is -7y equals -140, and then dividing y equals 20, so that was the thumb drives. And then we can substitute into either equation. I think I went with the one with the smaller numbers. So 2x plus 4 times 20 equals 88. So I'm just plugging that 20 in for y. So that'd be 2x plus 80 equals 88. Subtract 80 over. 2x equals 8, and x equals 4. So that was the notebooks, and then the 20 was the thumb drives. Number 9, Mr. Jones has $15,000 to invest. He invests part at 6%, the rest at 9%. If he earns $1,080 interest after 1 year, how much did he invest at each rate? So he has a total of $15,000 to invest. So there's 2 accounts. So we'll let one account be X, the other account be Y, and together that's 15 grand. And part of it's going to be at 6%, so I'm just going to put that with X. Doesn't really matter which one I do. And then the rest at 9%, so I'm going to say 9% of the money in Y, 6% of the money in X. Those 2 things together will make the total interest, which is right here. That's at 1080. And so then when I get ones that don't have very nice numbers, I just do the negative of the smaller number. And that just is by habit. You could also have done negative the larger one. It would just make 2 negative signs to keep track of. So I usually just pick the small one and then do that to the easy equation. So let me write this one down here. This would look like -0.06x minus 0.06y equals -900. And then here's this one, 0.06x plus 0.09y equals 1080. And so here we'd have 0.03y, and that equals 180 on this side. And then dividing that over, it looks like y is 6,000. And then remember, he had 15,000 total, so then something plus 6,000 makes 15,000. So x must be 9,000 when you do the back solve. Okay, a person spends $1,230 to buy stock in 2 companies. She pays $15 a share to one, $19 a share to the other. If she ends up with a total of 70 shares, how much did she buy for of each kind? So she's got a total of 70 shares. That means we're going to have x plus y equals 70 shares. And then we'll put 15 on x plus 19 per share on the y, and that's going to equal the total amount of money she spent, which is $1,230. So again, I usually just use the smaller of the two numbers, make it negative. So I'm going to do a negative 15 here, negative 15 there. And bringing that down, I get negative 15x minus 15y equals negative 1050. And I'll copy this equation down. And so here we're going to have 4y equals 180, so dividing y would equal 45. And she got a total of 70 shares, so that'll be x plus 45 equals 70. Bring that over, x equals 25.